Hi, I'm Nate Kokernot. Welcome to my channel. I'm in the middle of a discussion about the search for truth, and in previous videos, I've been making the argument that we're in a period right now in which the search for absolute objective truth has been abandoned for the most part by most people. Because we chose to go with this fragile peace treaty that says everybody's truth is true, and we should all learn to accept that. It is a hard truth to accept for those of us who value truth as a guiding principle, for those of us who assume logically that knowing what is actually true about reality would serve our well-being, for the simple fact that hitting our heads against reality and hoping that we'll break through is a painful way to go on existing. These same people imagine the potential chaos that unfolds from an agreement like postmodernism, especially when there are literally billions of different versions of supposed truth being tossed around and defended to the death by those who believe in them. I also think we don't have to imagine the world this produces, because all we have to do is turn on the news and we can see it with our eyes. It was a nice try, postmodernism, but it hasn't worked, and the reasons why it hasn't worked are quite explainable. So if we're going to really look for a method of investigating absolute truth again, we should understand the systems of research that we have chosen to investigate truth with, and see them for what they really are. Math and science are two such systems. I learned a lot about the scientific method from watching interviews with Donald Hoffman. This particular scientist is a breath of fresh air in my mind, because he states something obvious about science that most scientists just don't mention. Every scientific theory has assumptions written into it. Every theory starts with a statement, like, grant me that such and such is true, and I'll show you why this or that is also true. It works for both the sender and the receiver so long as they both accept the premise as true. These premises can also be described as axioms, which are the basic building blocks of math. If someone doesn't accept that the E in the equation E equals mc squared stands for energy, then the rest of the logic doesn't proceed for them. We are being asked in science to accept unproven assumptions that are embedded in every scientific theory. The scientists who are being honest will tell you that this explains why our best scientific theories, like the theory of evolution, still exist as theories, not as explanations or proofs. They're best guesses, and that is because if the premises that they're built on are wrong, then they would be wrong too. Science is based on the observation and measurement of that which we call reality, or space and time. It doesn't exactly take on the problem, at least not most of the time, that the meaning of things which we observe and measure can be interpreted differently by different scientists. And science hasn't really figured out an ideal way to account for that, other than to not get too big for its britches and start calling its theories something more concrete, like explanations or proofs. Math, on the other hand, which I know very little about because my mind goes into a bit of a fog when I look at all those symbols. I can't make heads or tails of what they're saying, simply because I haven't spent enough time familiarizing myself with the rules of the language that they're using. But here's what I've been told about how math works in contrast to how science works. When a new proof comes into the mathical lexicon, it goes through a peer review process that is different from the peer review system that exists in science. The scientists who do the peer review need to set up the experiment again in space and time, what we refer to as reality, and they have to do their best to set up the experiment with the exact same conditions that the original science team set up their experiment. In math, the peer review process is different simply because it stays in the abstract. It doesn't have to alter space and time in any way to see if the logic of math gets them to the same point. They just have to be rigorous in their computations, not make any mistakes. And if several qualified mathematicians land at the same symmetries as the proof, or they get the same answers when they add it all up, then it's accepted into the club. It's established as proven math. It works this way because it exists in the abstract. in our imaginations, and we could all be convinced of its truth if given enough time and enough explaining, because it is objectively true, according to the system of logic that is math. My favorite mathematician, Edward Frankl, makes an argument that math lives in an abstract realm that is shared by all minds. Even though some of its concepts don't exist on the level of space and time, take two parallel lines stretching into eternity. We can all close our eyes and picture this, but it doesn't exist in space and time. From our perspective in space and time, two parallel lines appear to meet off in the distance. But in our imaginations, we can know that they don't. We can imagine that if we transported ourselves to the place in the distance where the two lines appear to meet, we would find out that they are indeed still parallel. It was just an illusion that they met. Frankl says that the fact that we all possess the ability to imagine this, even though we have no previous experience of it in reality, is what makes it a higher order truth rather than a lower order truth. He compares it to the collective unconscious, which was a theory that the psychologist Carl Jung came up with last century. This concerns psychology. The collective unconscious concept is essentially a theory that there are abstract truths that pertain to all of us, even though we can't point at them. They're abstract. They exist in a realm beyond observation, but they can be implied by observations. Carl Jung was pointing at the symbols that populate the myths and legends that sprung up in various places on Earth that hadn't had contact with one another previous to them dreaming up their myths and legends. The similarities between different mythologies, though they were not relating to one another in physical space-time, is proof that we all share something in our minds that is not based entirely on observations of reality. The archetypes in Jung's theories are concepts like mother, father, trickster, hero, anima, animus, villain, snake, horse, and other general symbolic figures as well. They exist in an abstract realm of meaning, and yet they all generally agree that mother energy is this, while trickster energy is that. They're not pointing at the same concrete things as much as they're pointing at symbolic meaning given to those concrete things. On this stuff, it appears that we all agree more than we disagree, because all of our myths and legends have so many similar symbols in them. And dream symbols are also part of this synchronicity, and so Jung and others theorized that despite our different surroundings, due to our existing in different climates and different environments, we do seem to have some shared abstract truths. Frankl is making the same claim about mathematics, because mathematicians in India, South Africa, Mexico, and Iceland, for instance, can all, despite their different native tongues, agree on this language of math and this particular proof that they're all looking at adds up in perfectly the same way for all of them. Math can claim to be a system for establishing what is universally true. And guess who agrees? The scientists. The scientists know that they have to run their theories by the mathematicians before they can even be presented as legitimate theories. So I'm not saying here that science is an activity that shouldn't be pursued. It should be. It's great. But the limits of science do exist, and that should also be clarified so that we don't get confused into thinking that anything which science theorizes could be categorized as absolute truth. It's not. The premises themselves are there to prove, still. Donald Hoffman says the difference between a good theory and a great theory in science is that a great theory comes right out and states its limits. It admits that it's asking us to accept certain unproven truths, and it identifies them. It's a more intellectually honest form of science, and it is in fact what most scientists are respectful of. I think it is the drift in the minds of the consumers of science that is actually mostly responsible for the confusion that science is pointing at objective reality. I think that most scientists themselves do want to respect the true scientific method because they know that they would be ridiculed by other scientists if they stepped out of the line. I think it is those of us who consume scientific research but don't understand its processes well enough that make these assumptions and propagate them to others. They accept it as an imperfect system of seeking truth, but nevertheless a worthy pursuit in that it gets us closer to the truth so long as we maintain our open-mindedness about it and don't let it turn towards dogma, which is the same complaint that most scientifically minded people wage against religion and spirituality. The older forms of truth-seeking that have fallen out of fashion. All right, that's all I'm going to say today, and I hope that it was helpful. I hope that you'll hit the like and subscribe button to increase the exposure of ideas such as this one, which are getting lost in all the truths flying around out there. I am advocating for the idea of abandoning postmodernism because it has simply led to an overwhelming degree of chaos in the world, and because it's easy once you look at it more closely to explain why it leads to this chaos, and why moments like this one, where brute power literally trumps truth, forgive the pun, where these things have been allowed to happen in the first place by all of us abandoning the search for objective truth. Have a wonderful day, full of blessings and miracles, and I'll see you next time. Bye for now.